Looking at logarithms and functions, we're going to evaluate log functions and natural log functions. So we want to be able to go back between them. Now, you don't need to copy this down, okay? But looking at these different types of exponentials, can you solve for x just by looking at these basic types, okay? What would be the basic type for our first one? What would be the x value for 3 to the x power is equal to 9? What would it be? 2. A nice whole number, 2, right? 3 squared is going to be equal to 9. What about the next one? Cubed. Right, the exponential can go to each one of those terms. 2 to the third power is going to be 8. 1 to the first power is going to be 1. What about the last one? Negative 1. We're going to find the inverse by using the negative, right? Anything raised to the negative, we can use a reciprocal of this. Okay. It's typically easy to find these values because it's easy to understand the ideas behind exponentials, especially if they give you whole numbers or numbers that are perfect roots or cubes or squares to the actual numbers themselves. But what would happen if I give you a value like this? How would you solve that? Can we solve it in any conventional means of doing this? What's it, if you didn't know anything else, what could you do? Oh, there's a solution. No other conventional way. What about just guesstimating? 2 to the second power, 2 to the 2.2, 2 to the 2.3. Okay. We're going to look at how to solve this out. Okay. So I did not make this slide. Okay. I did not make this slide. Fancy, I know, right? Okay. Okay. What we're going to look at is being able to look at logarithms. So do copy down this. Okay. Looking at logarithms are going to be is pretty much a reverse way of helping us solve out values. Okay, especially using exponential types of functions. We're going to be able to use this and adapt this in order to solve out for exponentials. So the undoing operator, or the operator that's going to help us solve for exponentials, is logs. Okay, we're going to look at the natural log function and log function today. Okay. There's 2 ways we can rewrite it. We can change 2 to the x power is equal to 7 to log base 2 of 7 is equal to x. That's going to give us our exponential that's going to be equal to. A lot of the issues that I see with this test, especially when I taught integrated 3, is being able to identify the different types and converting them back and forth. Looking at both exponentials and logarithms to exponentials. You've got to be able to do both of them. Okay. The calculators have them directly. You can directly plug in log base 2 of 7 by hitting the log button, hitting the down button, plugging in your values, and simplifying. Okay. There is another way we're going to look at solving these, okay, but this is how we're going to do it. If you were to type in log base 2 of 7, we're going to get 2.81. Could you find this on your own? Yeah, by guesstimating. But if the numbers are really extreme, it'd be really hard for you to do that. Okay, so we are going to look at different ways of solving out these logarithms, okay? Now, the basis behind what we're doing here is the following. Go ahead and copy down this. The definition of a logarithm function. Let a be a positive number such that a is not equal to 1. Okay, if a is equal to 1 in this case, our base of 1 is not going to change anything. Okay, it's like 1 to the x power. Everything raised to any power is going to be 1. It's not going to really help us solve anything. Okay. We can convert back from each base. Log of base a of x is equal to y, which can be written as an exponential. A to the y power is equal to x. So you can interchange both of these. And in some cases that we do solve these problems, you're going to be needing to understand how to change them from both back and forth. Okay, back and forth. Sometimes you're going to use logs, sometimes you're going to use exponentials. And the form that we're going to take on is both a logarithm and an exponential. These are the bases of what you're going to see here. Okay, we're going to look at just being able to convert today and being able to just identify key parts to them. Flipping back and forth between each interchangeable portion is going to be key. Again, all this should be reviewed. You guys did cover this in Integrated 3. Expanding and condensing logs and converting and solving out. So we're just doing that. This is going to help us build for what we're doing. Now with this changing of base here that we're going to get here, we can write these in this form. Okay, this is another way to look at it. Okay, just as you had the acronym before that you guys used for like PEMDAS or Roy G. Biv, this is going to be the kind of acronym we're going to use for exponentials. I know it sounds dumb, but we refer to as Ben as a log bunny. Okay, where you can write this as Ben, Ben, is the log bunny. And bunny is spelled like bunny. Okay. Okay. Guys, please. Please. Okay. Ben is a log bunny. It's one thing that we can refer to it. Okay, it's going to help you change bases, and it tells you what each value is. B is a base number. E is an exponent. N is the number you're going to set it equal to, or N is the number you're going to get from it. And then log, we're going to apply the logarithm function for a base number, E, N, E. Okay. So this is how we want to be able to refer to it for these values and simplify out. It's definitely a way we can look at these, and they're interchangeable. Some of you guys already know how to do this, so you guys don't really need this, but it is an extra term that you guys can use in order to help you solve out. So these are both interchangeable. Again, being able to convert back and forth from logarithm to natural log is important. Or sorry, logarithm to exponential is important. Here we go. You do not need to create this chart, but I do want you guys to write down logarithm form and exponential form. So we're going to go ahead and just convert between both of them. If we're working kind of backwards, log is Ben. This is logarithm of base N of E to our exponential form and vice versa to so we want to be able to convert back and forth between these two. Okay, and it should make sense on how we're converting these. Again, we can match up the letters, our base number with the base number for our exponential. The number on the inside is the number on the outside for the exponential. And our exponent will be what it's equal to for these. So we want to be able to convert between both of these. If I'm looking at my logarithm, I know I have a base number. The small number that's down here is going to be my exponential. So something raised to another power. Whatever the number is equal to is what it's going to be raised by. So we're going to raise 10 to the 5th power. And that value should equal my inside value of my logarithm, which is 100,000. So being able to convert is going to be important for this. And you do have to do that for today's homework as well. So it's not hard. You just got to be able to make the changes. The most errors I will see on the test is people know how to solve these out, but when they rewrite them in log or exponential form, they mess them up. Okay, and you can't mess those up. Again, converting from logarithm to exponentials, my base number is 2. The outside number is going to be what it's going to be raised to. Inside the logarithm, log base 2 of 8 will be what it's equal to. So 2 to the 3rd power is going to be equal to 8. You guys remember doing a lot of these? Yeah. Okay. Good. Converting backwards now, if we're going back the other way, we're going to do the same thing. So we have our base number is 2, so it's going to be log base 2. Our internal number is going to be from what our answer is equal to, so 1/8. And whatever the exponential is going to be on the outside of that. A lot of these you're not going to need to use your calculator on today's homework. You should be able to convert back and just tell me what the answer is. And we're going to look at different examples of these. Even if we're given variables for the last one, we can still rewrite it. We're going to convert it into log. Our base number is 5. The internal number that's going to be represented by a log is going to be S, is equal to our R equal to R. So even though we could still convert back and forth between both of these. Okay, so that's the beginning portion of this. You definitely got to be able to convert back and forth. Okay, even if I give you the basics of one of these, the basis of one of these, are those two equal? Did I set this up right? It should make sense that when we do these, they should give us the right answers, especially like 2 to the negative third power is 1/8. If we're looking at other special properties that we get from here, these are our other special properties, so you guys don't need to know those. It's okay. Don't worry about that. Copy down those. Okay. These are special properties that come up with logarithms as well. Okay, so copy those down. It's going to help you out. Properties of logarithms still hold. Okay, we must raise a to the 0 power to get 1. So another way that their reasoning is explaining it in exponential form. So this exponential reasoning would be a to the 0 power would be equal to 1. So it's the same thing as log base a of 1 is equal to 0. The next one would be a raised to the first power would be equal to a. Right? Anything raised to the first power is just the number itself. So nothing of that changes. If we're kind of matching this, we're going to raise a to the x power. Well, it's going to be equal to x. Whichever those two are going to match up with. An exponential raised to the log power pretty much undoes the base power, which just gives us x. So I'll just leave that one alone. But applying these logs are going to be important for us to use in the future, especially when solving out for exponentials and solving and condensing logarithms. Okay, especially if I'm asking you for an estimated value, a simplified value, solve for the value of x, whatever it's going to be, you want to be able to convert it. It's the exponential version reasoning. It's what the exponentials are going to be reasoning for. So in this case, we have the logarithm base. This is a log base, and this is the exponential form. So it's another way to look at the terms. The logarithm property still holds, so you can still convert it back and forth, and you can solve it out that way. And sometimes it is easier to look at it that way. But it just depends on how you want to do it. So. And just below are just some examples of using those properties. And we're going to look at using those properties as well. Being able to just identify them and see what our answer is going to be. In this property, they're using base 5. We can use any base number we want to because it's going to be what the exponential is going to be raised to if we wanted to convert it. So it just depends on how you want to do it. Again, I'm grading tests. They look okay so far. I'm hoping to have them in by today. I wanted to do it by today, but I didn't have the luxury of finishing up because my baby was up last night. But be checking School Loop for the next couple of days so I can give you guys an update on the grades and stuff so you guys can see if you're missing anything or that you didn't turn in or that I have missing, that you guys can keep those updated. Especially going into this 3-day weekend so you know exactly what you have going into the week of Thanksgiving, at least, to keep those updated. So I'll update them by today, hopefully. More so likely today. I'm almost done with your guys' test so far. Okay, here we go. Copy down these couple of examples. Or sorry, the last thing we're going to need before we solve examples is using these. Okay, these are special logarithms. The common logarithms that you see on your calculator are going to be a log base 10 of x. So log of x is always going to have a base of 10. Changing bases, if it doesn't provide you that, I'll show you guys what it looks like. But your calculators always have a base of 10, so don't assume that log base 2 of 3 is the same thing as log base 10 of 2. Okay, 2 of 3. So we want to be able to identify those. You will see those. Another thing that we're going to look at is our natural logarithm, or ln. Okay, log base e, which we used yesterday for exponential, can be substituted for ln as well. Okay, ln is a natural log. This shouldn't be any new. This shouldn't be new, but okay, so just being able to go back and forth with this is also going to be the same thing. Okay. Oh, sorry. It's not ion, it's ln. It represents natural log. It's on your calculator. It has it there, ln. So let's look at these examples. So copy down these 4. We're just going to do 4 of these, being able to convert and see what the answers are. So just not as well just being able to convert, actually solving these out. So we're just going to solve for the rest, solving using the inverses, converting back to exponentials, that kind of idea. So we're just going to do these 4. We don't need a calculator to calculate these. You could just type them in and get an answer, but we're not going to. I want to show you guys that you can do these without the calculator. So even though this might look daunting, we can still do it. If we had to set equations equal to these values, we would say, let's say this is equal to x, this is equal to y, z, and let's just use r.
question from natural log, was it log base ex equals ln x or 1n x?
ln x. You're not doing all those problems though. Yeah. Now, in this case, what we're going to want to do is convert from our logarithm to exponential. Again, it's going to go from ben base exponent equal to a number to a log bunny base e of n of e. This is converting back and forth. This is using the acronym. You can copy this down. You can memorize it. What we refer to as ben is a log bunny. Just another way to rewrite the logarithm. So we're just converting. Look at our first example. If I want to convert this, all I want to do is be able to change my bases. So 4 to the x power is going to be equal to 64. What is x equal to? Can we find that out? What do I need to raise 4 to in order to get 64? 3. Very simple. So log base 4 of 64 might be a little bit confusing, but if you convert it back into exponential, it actually looks very nice. Number 2, if we convert this one, this would be 5 of z is equal to 0.2. Can I write 0.2 as a fraction? Well, how do I write 0.2 as a fraction? 2 over 10. 2 over 10 reduces down to, what would be z? Negative 1. The next one down below, we're going to go ahead and convert again. So this will be 1/5 raised to the y power is equal to 125. So these are just different ways we can look at logarithms. What would y be equal to? What was it? What did you have? Y is equal to, you just said it. Not -5, -3. Right? Negative flips the fraction to a 5, and then 5 raised to the 3rd power is 125. Our last one here, this was the one that was tricky. It was with all my kids. 36 raised to the r power is equal to 6.
Why did you use C, Y, and R?
I'm just using letters. I could have used x the whole time. Yeah. I'm just giving them different variables. Doesn't necessarily have to be the same variable. 36 raised to the r power is equal to 6. What was it? 1/2. Why the class didn't know that? 1/2. Right? We can always convert 4 to the 1/2 is just equal to 2. Right? The square root of 4 is going to be equal to 2. So that's another way to think about it. X raised to the 1 over n power is basically n root of x. So we can still convert back and forth between these. So whether we give fractions, whole numbers, or decimals, we can still convert. Okay. The next one we're going to look at is the following. So we're going to use these to evaluate the inverses. So copy down these 3. The properties for the inverses are also going to be held to what we want to be able to write out for these. So you guys copy down 1. What was the property for the inverses, or the properties that we used, the 1 through 4 properties? What was it? What do we have? What was number 1? Remember? A to the 0 power, but what did we write down? What was the property for that? Log A of 1 is equal to 0. What was 2? Log A of A is equal to just 1. What was the third property? Log a of a to the x is just equal to x. And the last property, which we don't really use that often, but we're going to use anyways, is log of a of x is equal to. So these are the properties going to hold up to. Okay. Looking at number 1, we want to be able to identify what property we're going to use. What property is it going to be used? The third one, right? The third one actually shows the same kind of idea where the 7s and 7s are going to be the same. That's going to tell us that whatever x is going to be our value, that's what our answer is going to be. It's going to be negative 3 of x. Negative 3x. If you wanted to convert it backwards and do it using the other property, and if you convert this, this would be 7 of whatever's blank there is equal to 7 of negative 3x. You can pretty much just match them. But this has to be matched with that, so you can set them equal. So that's what I'm saying. You can go back and forth between them both. Looking at number 2, yes. If they have to be the same number for us to use. If not, we have to use a different property. But we're just using the inverses, so they should be the inverses for the time being. Does that make sense? We'll get into more complicated times, but don't freak out over it. If you just use those properties, we're good. But yes, they should be the same for this moment. The next one we're going to do is, most people can't see this, but we got to be able to change this ln. So e to the log base e of 20. Which property does this stem from? The fourth one, right? The fourth one. So if they share e to the same log, okay, we're going to basically get that exponent or that number that's equal to it. So what is our answer? 20. Properties of exponentials tells me that e to the e can be reduced down. So we'll look at exponents and logarithms and how they go between them. So don't worry about number 2 that often. We'll show you guys more examples to kind of clarify that. Then our last one, if I want to convert this one, okay, this might seem a little bit more crazier than the other ones, but what we can look at this is 2 different ways. You can either write it as log base 2 of 2 to the, what is this? 2 to the, let me make sure. Yeah. 2 to the 6x. Can write it like that. This would just be what? 6x. Another way you can look at it as well is you can just rewrite this as an exponential. So the exponential term would be 2 to the 0 would be equal to 64x. Or you can rewrite it. 2 to the exponent will be equal to 2 to the 6th power of x. It's the same thing. It's the same kind of process. So as long as you're able to use these properties, these are where the properties are going to come into play. Okay, looking at both ways. So 6x is going to still be 6x. Just being able to convert it back and forth. So I'm not too, you don't have any, I think you only have like 2 problems of these on today's homework. So I wouldn't worry about it. Okay, that's it. Easy today? Okay, can I give you guys your homework? These are just looking at solving. Give me a second. I want to do 11 too, sorry. The first 6 problems, 1 through 12, you're just converting. So all you're going to do is change it from log to exponential, exponential to log, excuse me. So these shouldn't be hard, okay? The other ones, you got to be able to evaluate the expressions. So these are using the inverse properties for some of them are not. The bottom ones you're using to use the definition of x to solve. So you want to be able to rewrite them in either logarithm or exponential and solve those out. Mostly you're going to convert them back into exponential. What's up? It is also posted online as well. So it is already posted. If you don't have a good camera, it is posted online already.